Hello world viewers, what's up? I hope all you are doing well and your neos and deos are also doing well. In the previous video I start about something that is electromagnetic field theory, right? And the first lecture has been happened. If you don't watch that, then go to watch, and I will make a playlist of this theory actually, and it is a part of the syllabus. That's why I uh, teach you, and I also learning about it, and it will be helpful for your engineering subjects as well, for your graduation subject as well, right? So it is very essential subject. And in the last video we have discussed about the various forms of the equations, in the differential forms of equations and integral forms of the equations. Good morning, good evening, good night, according to their substances, in the morning, in the evening, in the night. Okay, so it is the all the scenario, and today we are going to derive the equations. The equations means it is the differential equations and the integral form of equation. We will derive part by part. I will derive first the integral form equation because it is very short and very simple, and it will be closed by only one lecture or one video. So today we will derive integral form of the Maxwell's equations. Okay, so we'll derive this four equation, 1 2 3 4. Okay, so after that I will derive these equations, and it is more lengthier than this. That's why I today derive integral form of equations. The first equation we have to derive, that is surface integral of d dot ds is equal to volume integral of rho dv. Okay, so this is the first equation we have to derive. What we have to derive? And this we have to derive that the surface integral of d dot ds is equal to volume integral of rho dv. So what is d? I have told you. So d is that displacement density. Okay, so displacement density here. So it's the rho volume charge density. Okay, so we have to derive the. So where are the clue? Okay, where are the clues? We have to derive this. So these are the clue here. We have the differential equations at first. Actually I have to derive first differential equation, otherwise it is very simple, because we have the clue that divergence of d is equal to rho. We know it, we have this, that's why we know it. So we have to derive this. Our aim is to derive this. This is our aim. Okay, so we have to do in the volume integral, okay, in the right side, and the surface integral in the left side. So let's say first we have just do the volume integral on the both side. If you took volume integral on the both side, then what will happen? Let's say, so if you do the volume integral, that means it will be, the volume integral symbol is like this, and it will be divergence of d dot dv. When it's volume integral, it is dv. Don't be confused in somewhere. The volume integral is writing like this. This is x, y, and z. X, y, and z. That is the volume integral. And how it looks, it is a divergence of d, dx, dy, and dz. So don't be confused about that. Volume means the length, breadth, and the height. The three things will be represented. That's why in some books these are symbolized like this. Don't be confused. In the single frame we can use direct integration, then b, then dv. Okay, so don't be confused about that. Okay, in the right side we will write that the volume integral of rho dv. So in a closed surface we have to surround that. This is the closed, because in surface it can be closed or open, but in case of volume it is always closed. That's why it doesn't need any kind of symbolism like this, closed integral or open integral. Okay, so this is the scenario. So here we have got this kind of thing. We got the RHS part, but we have to got the LHS part. For the LHS part, what we have to do? Okay, what we have to do, that is very much important. So we have use. Okay, we have to use here a special, I say, instrument to change this volume integral to surface integral. So what is that instrument? That instrument is very, very fantastic. Gaussian divergence theorem. What is that? Gaussian divergence theorem. What it does? Gaussian divergence theorems is just do the surface integral to volume integral and the volume integral to surface integral. It is just a converter. And that's why I tell it the instrument, because it will help us to change or rectify or change it to volume integral to surface integral. Okay, so using Gaussian divergence theorem. So what is the application of it? It will change the volume integral to surface integral and vice versa, to surface integral and surface integral to volume integral. That's why we use the word vice versa. Okay, so volume integral to surface integral to volume integral. So what will happen here? We are using the Gaussian convergence theorem in the left hand side only. Okay, in the left hand side. So what will happen here? Here the divergence will be outed. The divergence symbol will be outed, and the dot symbol also will be outed at the same time. Divergence means it is with that. Okay, the single delta is called the gradient, but the gradient with the dot is called the divergence. That's why it will remove out, then it will convert it into S. Okay, because we convert volume integral to surface integral, and this dot will be converted out and this will be vanished out, the divergence, and it will be only d dot ds. So d dot dv will be ds, right? So is equal to rho dv on d with respect to v. Very simple, very simple. We got that point. Okay, we got that point. We prove the first equation. Okay, we prove the first equation. The first equation is completed here. Okay, don't to be worried, there is no much different things or very happening things. So you just write it perfectly, right? Don't to be forget to do the signs of the arrow mark. The vector quantity you have to decide. You have to symbolize. So don't to be forget that, right? So this symbolization and writing styles plays a major role here. Okay, when you are writing the answers. Okay, so this is the first equation derived. Let's go to the second equation. Okay, I erase it. Don't worry about the notes I say, because there is WhatsApp channel. Still, you should taking the notes when you are watching my videos, so it will be very good for you. Otherwise, it will be uploaded on my WhatsApp channel because I have made for you. So I'll erase it. Okay. So when we go to the second equation, what is the second equation we have to derive? The second equation is that surface integral of b dot ds is equal to 0. We have to find. This is our aim here. This is our aim. So what we have the data? We have the data of differential equation, that is divergence of b is equal to 0. Okay, we know it. We know it before solving this. So what is b? B is the magnetic field. I said b is the magnetic field. Okay, what is the formula for it? Magnetic flux upon area. Magnetic flux upon area. So the magnetic field upon a closed surface always is 0. We all know it. Okay, so don't worry about that. So this is the statement actually. This is the statement, and we have to do these kind of things. So what we have to do? What we have to do? Here there is nothing. There is nothing also. So firstly we have to do. So to get it, firstly we have to remove the divergence symbol. Okay, we have to remove the divergence symbol. How can we remove the divergence symbol? You say that directly we took the surface integral on both sides, then it will be problematic. Why? Because directly if we took out, the divergence will not be removed. So what is the? How can we remove the divergence symbol? First we have to convert it a volume integral. So let's take volume integral on both sides. Let's take volume integral. So what will happen here? Here it will be b, symbolized b. There is no need of any closed circle because volume always enclosed. That means it will be divergence of b dot dv is equal to 0. Okay, so here we got this kind of scenario. So we have to get to surface integral because we have to remove out the divergence symbol. That's why we do it. So what do we have to do? There is instrument in the previous equations. I use it. What is that? What is that? That is the Gaussian divergence theorem. Gaussian divergence theorem. So what is the role of it? Surface integral to volume integral to surface integral, surface integral to volume integral to surface integral. It is the role of that. That's the instrument. Okay. So what will happen here? Here the V and the volume integral will be surface integral, and the divergence will be removed out, and it will be only d dot don't be forget about this dot ds. It will be ds is equal to 0. So this is our equation. This is our required equation. That's why I took the integral form part, because it is very much simpler as compared to the differential equation derivation. After this video, I will derive the differential equations derivation, right? So don't be worried about that. Okay. So this is the second equation derived. I will erase it. Don't worry about the notes, because there is WhatsApp channel. Okay. I will erase it. Erase. Okay. We are going to the third stage. What is the third equation? What is the third equation we are going? The third equation is linear integral of b dot dl. The third equation is linear integral of b dot dl is equal to minus divers upon divert t surface integral of b dot ds. So this is our third equation, and we have to derive it. Okay. To derive it, what we have the data? At first we have to say we have the data that in the diversion third equation, what we have, that's curl of E is equal to minus divert B upon divert T. I just want to told you that what is divert B upon divert T. Why it divert B, divert T? Why d and dt? Okay, of B and divert B upon divert T. What is the difference between this and this? Okay, I will tell you. So in case of here, what happened in the d upon dt, here only the relative term is time. Okay, on the relative term it depends upon, B depends upon time only. But what happens in case of that, B depends upon T as well. B is the magnetic field here, so B is equal to phi upon A, that is magnetic flux upon area, that it also depends upon the area. That's why it depends upon more than one. When something is depends upon more than one, when in case of derivation, then it will convert into partial derivation. The simple derivation will convert into partial derivation. That's why B depends upon more than one quantity. That's why it is in partial derivation. So this is the difference between this and this. We'll do the in the mathematics classes. What is the derivation? What is partial derivation? What is integration? Okay, we'll do those kind of things. So this we have the data. This we have the data. So taking surface integral in both sides. So taking surface integral in both sides. So what we have in both sides? If we took the surface integral, then it will be is divergence of E dot ds, okay, is equal to minus surface integral of B dot ds. Okay, this thing we got here. Okay, so this is the surface integral of this part and the surface integral of this part. Then what will be the next? We have to find the curl. We have to remove out the curl. So how can we remove out the curl? To remove out the curl, we have to do any kind of theorem, Oda's theorem. Okay, so for that Gaussian divergence theorem, like this, here also there is a theorem, that is Stokes theorem. Sorry, Stokes divergence theorem. Here there is only another theorem. Apply Stokes divergence theorem. Okay, so we will apply the Stokes divergence theorem. What will do? It do the linear integral into surface integral and surface integral into linear integral. This is the simple application of this theorem, and it will do the curl that remove the divergence. It remove the curl. That means here this symbol will be vanished out. This symbol will be vanished out. Here is the dot. Here is the dot. Also the right side we have got already. We have got already, and it will converted the surface into linear. That means right hand side already ready. So we have to just apply the Stokes divergence theorem in the left hand side. So what will happen here? It will L L E dot dl is equal to minus diver upon diver t. So right hand side is already ready, so there is no need of any change. That's why here in the left hand side it is E dot dl. Okay, E dot dl, or we can say it as B dot dl as well. B dot dl. So it will be B dot dl is equal to minus B dot ds. So we got the third equation as well. So there is no any critical things here. Very simple. Just apply the Gaussian divergence theorem, Stokes divergence theorem. The two theorems we use here, that surface to volume and here linear to surface. That's the simple application happened here. Okay, I will erase the third equation. Okay, don't worry over the notes because there is WhatsApp channel. Okay, so I will remove. Then what is the fourth equation we have to write? Fourth equation is linear integral of h dot dl is equal to surface integral of j plus diver d upon diver t multiplied by ds. So it is our aim in the fourth equation. This is our aim here. So what we have? We have that clue in the differential equation, that is curl of h is equal to j plus diver d upon diver t. What is j? J is the current density. And d, this is the displacement current. We all know. How is the application of it? You don't know it? I just told. Okay, these are the application of that equations. So what we have to do? We have to do here the curl. We have to convert it into the dl section. Okay, so firstly we have to take. So directly, can you take that? Here is the linear. So we have to convert first linear to surface, then surface to that target. Okay. So first we just take, because we just do the right things from both side. Okay, so we'll do the surface integral on the both side. Let's take surface integral in both sides. That means in this equation we just use the surface integral in the both side. So what will happen in the next? Let's say, so here b curl of h, it will be surface integral. So the symbol is s here. So it will be curl of h ds is equal to surface integral of j plus diver d upon diver t ds dot. The dot should be there. Okay, so we got this point. So here we have to just remove the curl symbol. How can we remove the curl symbol? The instrument is the Stokes divergence theorem, like the Gaussian divergence theorem. To remove the divergence, to remove the curl, Stokes theorem. So the Stokes theorem here, we use Stokes theorem to use. So no need to be apply in the right hand side, because right hand side already is ready because it is in the ds. So in the left hand side it needs to remove of the curl as well. It have to go to the linear section. That's why I use curl. What is the function of the curl? That is linear to integral and integral to, I mean to say linear to surface and surface to linear integral to surface integral to linear integral. This is the function of that. Okay, so we'll do the the call will be removed out. That means it will be converted into L H dot ds will be dl is equal to, in LHS, is equal to surface integral of j plus divert d upon divert t dot ds. Okay, this is our required equation. This is our fourth equation. This is finished. This is finished, and it is simple, actually very much simple and very completive way. And basically the examination, the other differential equations derivations asked much more time, but it is also sometimes asked. That's why you should be all prepared. And it is not the only two equations, that Gaussian divergence theorem plays a major role, Stokes theorem plays a major role. These two equations do everything to you, nothing you have to do. Okay, so it is finished here. In the next video we'll derive these equations, first equation, second equation, third equation, fourth equation, step by step. Thanks you for watching this video. Not forget to subscribe this channel, share this channel, like this channel, and comment this channel, especially your doubts. I just want to know. Okay, then I will give you the answer. Thank you for watching this.